Welcome to Evo 10 ECU Flash Training Part 7. In this video, we're going to take a look at our injector data programming and characterization data. So what we'll find is that when we want to convert our fuel mass that we've calculated knowing our air mass and our target air fuel into actual fuel mass, into an injector pulse width, we need to know some things about the fuel injectors. We need to know what the injectors flow. We need to know some characterization information, so how the injectors respond at different battery voltages, and then also the linear and nonlinear operation zones of the injector. We're going to find that all of this will allow us to characterize the proper injector pulse width to open and close the injector to deliver the precise amount of fuel that we're calculating in our fuel mass, so that the engine is going to be hitting the target air fuel that we're requesting and we'd like to run at. So it's very important that the injector data is going to be programmed properly. I'm going to be going through some examples of how to program it. I've supplied some injector data so you can do copy and paste between a lot of the more common injector sizes for Evo 10 applications. So without further wait, let's jump into this video so we can check this out.
Okay, so let's get started. We're going to be taking a look at our fuel injector programming in our ECU Flash software for our Evo 8 applications. Now, in the last video, we learned how the mass airflow and the speed density tables are going to interact. Let's just quickly review that because it's going to play a role here in our injector data, and we need to kind of understand how everything's going to be interconnected. So in our mass airflow or speed density modes, we're going to have our tables that we have to deal with here. So we have our MAF scaling table. We also have our map table. So in the mass airflow mode, we're going to have our MAF sensor that's going to be a 0 to 5 volt sensor. We can see our scale here in our table. So it's going to start off at 0 volt, go all the way up to 5 volt. Depending on how much airflow is coming in across our mass airflow sensor, it's going to be registering a certain amount of voltage. It's going to go into our table here and figure out what that amount of airflow is going to be. So the mass airflow sensor is only going to register the airflow. It doesn't take into account the intake air temperature and barrel pressure. That's a density portion of the calculation. So if we're talking about what's entering the engine, it's going to be air mass, not just looking at the volume of air entering the engine. If we change our elevation, and if we go from sea level to 5,000 feet elevation, we're going to find that the air mass entering the engine is going to be quite different, and we need to scale our fuel accordingly. So it will be very important that we understand that this is going to be registering airflow. The other portion of that, it's going to be taking a look at the intake air temperature and the barrel pressure, and then that's going to be scaling out the density portion. So we learned in our very first video in our training course here that mass is equal to volume times density. So air mass then would be the volume of air and then the density of the air. So we're going to have our volume from our mass airflow sensor, the density coming from our intake air and barrel pressure going in and calculating everything. So that's going to be how it registers air mass in the mass airflow mode. Now, if it's in speed density, if it's taking a look at the map pressure, we're going to find this table based on engine RPM, based on our map pressure here at the top. We can find it in the scale. This is going to be the estimation of airflow coming into the engine. So we're estimating here, we're actually measuring it here. It's going to be the difference of the two different kinds of calculations going on. So when we're in our speed density mode, we're going to find that we still have our estimation of airflow. Then the density portion is going to come from the intake air and the barrel readings. So this will be the volume times the density of the air. Therefore, we'll have our air mass coming into the engine. So this is going to be an estimated amount of air mass. This is going to be a measured amount of air mass. And our volumetric efficiency speed density calculations are very, very accurate. So we can rely on these values that we have here to be very, very useful as far as calibrating goes. It's not going to be way off, or we're going to find that it's going to be an inadequate way to work with tuning our engine, but it's going to have, again, the both calculations going on. So we know what the air mass will be. Now, if we scoot up here in our table, let's kind of move some of these out of the way so I can just scroll up here. We're also going to find we have a high octane table here, so high and low octane, but right now we're just going to have a, looking at the low octane is all we need, or the high octane here, it's all we need. We're going to find this is going to be the target air fuel that we want to run. So the way this ECU is going to work, it's going to be using an underlining basic equation. It's going to be fuel mass is equal to air mass divided by target air fuel. So we know what the air mass is going to be either in a measured amount from our MAF sensor or an estimated amount from our speed density. We're going to be specifying what we want the target air fuel to be at based on engine RPM, based on load here. Now the load is calculated. You see our values here from 10 to 320. The load is calculated.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.